Yeah, thank you so much. And welcome everyone. Um, let me charge my computer real quick. It's dying. But yeah, welcome everyone. Don't know what else to say. Thank you so much for the introduction. Um, I think we're in for a long presentation, so um, let me just get started. And again, thank you everyone. For this opportunity for me to like fill you guys in on some of the gaps in history. I know a lot of us didn't learn a lot of this in school and throughout our life, even living here in the Salinas Valley. So I think it's incredibly important and um, it allows us to really get a sense of direction as um, to what exactly we should do moving forward in this society that we're living in. But yeah, let's get started. So I have the little otter here, of course, and a picture of the Monterey Canyon. So I really wanted to start defining some of these things, Salinas, the Salinas Valley, etc., so we could get a collective understanding of what exactly we're talking about. So, of course, the Salinas Valley, a lot of us may know that it's called the salad bowl of the world. Some of the little facts that I wanted to share are that it produces roughly half of the nation's lettuce and nearly 80% of its artichokes. And it has an estimated value of 8 billion to 10 billion what this agriculture produces for the world. And here's a little picture of what the Salinas Valley encompasses. So it goes all the way down to Bradley and comes out into the Monterey area. Okay. So Salinas, where exactly does this word come from? It actually comes from the Spanish word, so sal, salt, saline, etc. And this is because of all the salt marshland that existed when Europeans actually first came into the valley. They said the salt content was abundant. Um, and there's this local legend that I wanted to share. In the 1850s, not sure exactly how true it is, but it is, again, a local legend where a man walked into this meeting with a fistful of salt from a pond nearby. And he said, Es Salina, which means it is salt. And the group decided to call the area Salinas. Um, so yeah, a lot of the area was named after this. That's why we have the block, the Salina Formation, Salinas, Salina Valley. And the we have the Salinas River that runs through the entirety of the valley. And it's also sometimes called the Upside Down River. And it's one of the few rivers that in the US that actually flows north. Um, through the tilt of the valley floor. And it's called on the upside down because most of the river actually flows underground through aquifers. So sometimes you may be walking through the Salinas River and there's almost no flow in sight. It's almost like a little desert. It's completely dry, just sand. And that's because most of the water flows year round underground. And that's because of the geomorphical like processes that occurred throughout the millions of years. So, um, I'll get into it. So here's somewhat of the tilt in the valley. So as we can see in the bottom, there's actually a granodiorite bedding that starts a little bit higher in the San Luis Obispo, so the southern portion of the valley, and flows down into the mouth of the Monterey Bay and Monterey Canyon. So here's like a little picture. I'll dive more into it as we proceed in this presentation, but as mentioned here, in the San Luis Obispo area, it's actually 1,000 feet higher than at the end in the Monterey Bay and before it goes into the Monterey Canyon. So it kind of doesn't have any other choice but to flow north rather than westward into the Pacific Ocean. So I think that's something interesting to note. Here's also like the 180-foot aquifer and the 400-foot aquifer that we use in the agricultural industry here in the Salinas Valley. So, um, another thing that I want to note is that the Salinas Valley is formed And it's um, called the valley because we're in between two mountain ranges, right? We have the Santa Lucias to the left, as you can see, and the Gabilands to the right. So the Santa Lucia range, I put a little picture up here of Cone Peak, which is the tallest coastal slope in all of the US and the tallest slope of the Santa Lucias. And it rises 5,158 feet above sea level in just 3 miles. So it's one of these dramatic drops that makes the Big Sur and just the California coast really unique in the whole world. There's only a few other areas that are right next to this continental like drift and what do you call it? Like the coast where it's dramatically just falls next to like a giant like mountain range. And the Gabilands to our right of the valley, named after the sparrowhawk. And we can see here a picture of Fremont's Peak, which is the highest point. As you can see here, it's the highest point in the Gavilan Range, which again is to the right. And another important thing that I want to cover is the Selenian granitic rock, which is granodiorite. And that's really important because it forms the whole base of not just the Monterey Bay, but the Salinas Valley in total. And many geologists had this thing that we call the selenia problem. No one really knew how exactly it got there. It's kind of like randomly in between coastal mountain buildup, and it's just there in the middle. And that's something that we'll be answering and diving into some of these answers that geologists figured out. So I think in order to fully understand the selenium problem, we need to look into the formation of the Sierra Nevada range. So the story starts 300 million years ago. And this was the Carnivorous to the Permian era of the world. And as we can see in this picture on the right, it's like how it actually looked like during the time. And then on the left, we kind of see some of the countries and where they kind of fit in. So if we look at it, there's this shelf where California stands today, and it was a really shallow sea. So there was tons of marine invertebrate, crinoid forest, and we were part of the supercontinent Pangea. It had not yet split up 300 million years ago, and it was just starting that phase. So here are the crinoids, sea lilies, which we have still in the Monterey Trench. Some of their ancestors, we have brachiopods, graptolites, trilobites, of course, bryozoans, and my favorite, the cephalopods. I feel like they just look like Pokemons when you think about it, but these are like the creatures that lived in the Pacific Ocean 300 million years ago. So when we were still part of the Pangea coast. So fast forward 100 million years ago, and we see the beginning of the split of Pangea. So we have these rift zones occurring here um, in between South America and North America, Africa, North America, and Eurasia, North America. And what would happen was basically they started cracking, and as magma started flowing, it was filling up those cracks, and, and shortly but surely it caused drift. So it caused that um, gap to widen and widen. And then with sea intrusion, it created the Atlantic Ocean, which just fast forwarded that momentum and started pushing all the plates across. So during this time, around 200 million years ago, there was a bunch of island arcs along the coast and North America. So those arcs actually started subducting and crashing into North America, or what was to become California. And this is the precursor to the Farallon plate that we see later. So just imagine all those islands crashing into the coastline, and this is where we really see the California coast begin to become something. So here we have all those islands being crushed into the coast, forming this island arc in North America. And this is what we call today the Western Metamorphic Belt. And it's made out of coastal crust and coastal islands. And this is also where a lot of the gold in the foothills of the Sierra Nevada area actually came from. So we see it today. And then here's a quick overview. So the Central Valley sort of began forming during this time. Here, if we could imagine it, the Fork Basin is the Central Valley. The Sierra Nevada would be um, from the bubbles, basically. This plate subducting, creating bubbles and rising up the Sierra Nevada volcanoes. And then we have accretionary wedges, which I'll dive into. And we don't really see a dry um, Central Valley up until 1.5 million years. So we still have a long way to go until then. And the Sierra Nevada completely comes up to the point where we kind of see it today, mostly around 10 million years. So the Sierra Nevada really started 100 million years ago. And here, a accretionary wedge. Um, so the way it kind of works is that there's a bulldozing effect from the Farallon plate. So we have the North American plate and the Farallon plate. They struggled for a while, caused major earthquakes, but the North American plate has a whole continent on top of it, so it's super dense. So this caused the tectonic plate to actually subduct and go under the North American plate. With it, the North American plate started bulldozing certain islands onto the continent. That's where we get some of the arcs, some of the islands crashing into North America. And everything that dropped under the coast, think about it like dropping something in water. All those bubbles that come up create pressure, which create magma, which create volcanoes. And that's all the Sierra Nevada really is. So we see the subduction of the Farallon plate here, 150 to around 80 million years, that caused this activity in the Sierra Nevada range. So here are a few more visuals and pictures so we can really understand um, the Sierra Nevada range popping up here with that magma, Farallon plate subducting, creating those bubbles. So we really have these ancient Sierra Nevada range of just volcanic mountains. Here's another visual. And this is where we see the origins of the Ring of Fire. Once the Farallon plate subducts into the North American plate, it causes incredible magma bursts throughout the world. And the Pacific plate takes up 1/3 of the world, so it is absolutely huge. Here's a picture of the coast 130 million years ago with those ancient Sierra Nevada mountain ranges popping up. We can see it right here, and it creates um, what we know as the coast 100 million years ago. So here we see once the Sierra Nevadas start forming. So the Sierra Nevadas we see today are nothing like the ancestral Sierra Nevadas. So the ancestral Sierra Nevadas were just volcanoes here. So all the mud, dirt, and stuff that was on top. So they were much taller than they are today. And the Sierra Nevadas are actually the magma that cooled under. So we can see it here with the pink um, here again, with the brown is what the Sierra Nevadas were. So after all those years, we had erosion. It cut all that dirt. And what we had was the batholith, the Sierra batholith, arise, which we have today. So the coast 5 to 10 million years ago, um, this is what it looked like. And this 10 to 5 million years ago is when we really see most of the Sierra Nevada rise up above sea level. Um, so here again, here's a picture with most of the growth that we see was 3 to 5 million years ago, and it's still rising up to this day. So it's a fairly young um, mountain range. So now we know how the Western Metamorphic was islands and coastal debris sediments that crashed into the North American plate. And now we have the Sierras, which actually rose up from erosion and volcanic magma cooling. So the Salino block, right? Now that we know how the Sierra Nevada range, how it was volcanoes, it created a super long mountain range, we can really start to solve how the Salino block came to be, which is basically what forms most of the Monterey and Salinas Valley. So again, here's the coast 130 million years ago. The Sierra Nevada was pretty much the coast. We have a few islands that make up a little bit more of what we know now as the California coast, but pretty much most of the coast was in the Sierra Nevadas. We did have a shallow sea here, which created even more sediments for the Central Valley. So 30 million years ago is when the Farallon plate that was subducting under completely went under. And we saw the Sierra Nevada stop producing magma and drying out. But this led to a series of additional volcanoes occurring, which we see now, the remnants like Pinnacles in Soledad, um, which this basically was a volcano that dried out and it shifted here. It started in Lancaster. This is where the volcano was, and through the San Andres, it came all the way to Soledad. So that's 250 miles of travel. Down in the slow area, we all of us know Morro Rock. That's also a volcanic plug that was active 26 million years ago and dried out, and all of the dirt on top eroded. So that's one of the nine volcanoes that actually exist in the San Luis Obispo area. They're called the Nine Sisters, as we know it. And here they're in a very linear fashion throughout the coast. So we could see Morro Rock, Black Hill, Cabrillo Peak, Hollister Peak, Cerro Romaldo, Chumash Peak, Bishop Peak, Cerro San Luis, and Islay Hill. So there's various islands out in the ocean, and growing up, I always wondered why these random rocks were super out there, and it has to do with the San Andres Fault. Um, so the San Andreas Fault occurred post in around similar time, 30 million years ago, to the Farallon Plate completely subducting under the North American Plate. The Pacific Plate actually ended up crashing at some point, and through all this immense pressure, they were basically almost tied. The plate was not able to subduct under, and what ended up happening was a slit. So now, instead of it going under, we have the San Andres and the North American plate sliding up. So we have the San Andres or the Pacific plate sliding up north, and we have the North American plate moving down. So here's some visuals of the San Andres to the left, that fault line, and here's some ways that we think the world and the California coast is going to be affected within the next few million years. So, 25 million years, scientists think that um, LA will be approaching San Francisco, with the Monterey area being already at San Francisco. 50 million years ago, LA will be right next to San Francisco. And then in 250 million years, LA will be right at the tip of the bottom of Alaska. So, it's still this process is still going, and most of the earthquakes that occur are due to this slip. So the coast 50 to 30 million years ago, we see the Salinian block begin moving during this time and begin its 300-mile long trek from the San Andres. So the Selenian block is actually the very southern tip of what we know as the Sierra Nevada range. And it is not until 20 to 15 million years where we see most of its initial um, journey. And this is where it starts moving a little bit quicker. So here's 5 to 10 million years later. And so the Selenian block is actually, how I said, the southern tip of the San Andres Fault. And we see this granodiorite layer be exactly the same structure, the same type of rock as the Sierra Nevada. And here's a little animation of the Salinia block moving. So we see present location of the Monterey Peninsula and the earliest location of the rock with the X. The Farallon plate, which is the one that's subducted right under the North American plate. And if we track it with this black arrow, we can see some of that movement. Once we reach here 18 million years, we'll see the movement begin to occur. So here we got to the 18 million years. It starts moving up to that white dot, which is present day Monterey Bay. So let's see that portion, that last portion a little bit. So it begins here around 20 to 18 million years and make its way up to its present range. And another geologic anomaly that we really see in the area is the Monterey Canyon. So this Monterey Canyon is deeper than the Grand Canyon, which is already a crazy fact. And a lot of people think that the Monterey Canyon was formed 21 to 30 million years ago while this fault was starting to move. So this is where we see a lot of the origin and a lot of the ancestral rock of the Monterey Canyon begin to erode. And this would have formed in the Santa Barbara, Los Angeles, Mexico area. And through the Central Valley drainage was 3 million to 600 thousand years ago. So the Central Valley was, for the most part, flooded. What people think was the Lake Corcoran that ran across the whole Central Valley. So this massive flow of water was thought to escape through the Salinas River first before completely blasting through the San Francisco Bay area. And this deposited large amounts of sediment into the Monterey Canyon. And with the modern turbidity currents, this is where we think that 3 million years ago, up to the present times, that the Monterey Canyon really started to carve itself out a little bit more, and it's continuing to through this day, causing landslides where all the sediment basically concaves and creates increasing depth. So here are some of the theories of the Monterey Canyon um, through its um, geologic creation 21 to 30 million years ago. So some geologists believe that the Colorado River might have been what carved out the Monterey Canyon. So we now see the Colorado River flow into the Gulf of California. But before Monterey Bay would have been around this area. So some people think that it would have flowed west into the Pacific Ocean and carved out the Monterey Canyon. Others believe that the Sacramento and San Joaquin River might have flowed in through the Santa Clara Valley and dumped out Monterey Bay. So we see it now flow through the San Francisco Bay. So the Monterey Canyon is over 10,000, around 10 to 12,000 feet deep, making it deeper than the Grand Canyon. So we can see the chart to the right. The Grand Canyon is 6,000 feet deep. And here's a little map also of the Monterey Canyon. And we see the stream, the underwater stream that was created. Here are some of the things that exist under the or throughout the Monterey Canyon. So some almost alien-looking creatures. To the bottom right, we have the barrel eyes, which is my favorite organism that's found down there, which actually sees through its head and has a translucent head. So now let's try to understand how the Salinas Valley formed out of this. So let's go through parts of the ice age to understand some of the hydraulical erosion that occurred. So 150 million years ago, um, this is what the US looked like. We then had an inland sea cut out a lot of the middle of the US, and California is still pretty much underwater. It is not until 100 million years that we see more of the coast form due to the subduction of the Farallon plate. And then 60 million years ago, we see more of the creation of land. And around here in the middle, we see most of the coast being formed, and it is not until these last years, around 3 to 5 million years, that we start seeing the modern California coast really pop up. But by that time, 2 million years ago, we see the ice age really start taking effect on California. 16 million years ago, to 6 million years ago, we have what we know as Monterey Formation. And we have a lot of these clues because of the rock um, that is built on top of the granodiorite in the Salinas Valley. So here is what we know as the Monterey Formation. And this was basically since these times when we were underwater, lots of organisms would live within the center of California. And as animals began to die, they become layers in the ocean, in the shallow sea. And throughout their death, they would sink to the bottom of the valley, and layer on top of layers, eroding mountains would pile up. And this is where we really see the San Ardo oil and all these oil ranges really pop up. So the Monterey Formation was mostly built on plankton and other small-shelled organisms. When they died, they created this layer 16 to 6 million years ago that created the oil that we see in California. And this is what we call the Monterey Formation. And we can see that the Salinas Valley is comprised of a lot of this Monterey Formation. So, when did that last ice age end? This is a big question. So, a lot of us think that it ended like much longer than it actually did. So, what we know is that the ice age only ended around 11,000 years ago. And here's some visuals that trip me out when I look at them because two-thirds of the what we know as the North American continent was covered in this ice sheet. The biggest one covering was the Laurentide ice sheet, as we can see here. And it went all the way covering New York City, went super inland here, passing like Chicago area, and then we had to cover most of Washington, or half around there, like I think the tip of Washington. And this uh, layer of complete ice was super dense. It was around, I think the depth was 2 miles of complete ice. It was so heavy that we had the North American continent actually begin to drop from the top north, and it created an uprising of the southern portion of North America. So the crust was being pushed into the Earth's mantle, and it caused subduction of the entire top northern part of North America. So this is why we see regions like in Mexico, etc., with higher elevation. And this is shortly sinking again as we've escaped the ice age. So the southern portion of North America is actually starting to dip again, and we're starting to see a little bit more flooding. So here's a visual. So it reads from right to left. So this is the present day on the left side. And here's the temperature in Celsius. So here we see the first major melt of the ice age, which there was another freezing again during the Younger Dryas. And then we started with the melt again of the ice age around 11,000 to 10,000 years ago. And around 700 to 800 years, we have what we call the Little Ice Age here, in which temperatures around the world started cooling again. So here's the coast 130 million years ago. And this is when we saw more of those sediments really begin to fill the Central Valley, which we now have 40,000 feet of sediments um, filling up. But um, fast forward to 600,000 years, we had this massive inland sea, which created and gave depth to the Central Valley, further eroding the mountainsides and creating those sediments that we see today. And this was due to the exit of the Ice Age. So we had large glaciers on the Sierra Nevada, some of which are still present today. I think there's around 12, quite small now due to the global warming and the warming of our environment. But we have the Palisades, um, like a glacier being part of this as well. So this is 600,000 years ago is when we really see the unflooding and the last flooding of this area. And it is commonly thought that um, as the ice melted, it began exiting through what we know as the Salinas Valley, and then the as we started exiting the Ice Age 11,000 years ago, it was unflooding so fast and melting the glacier so fast that it burst through the San Francisco Bay. So here we see other pictures. So Lake Clyde and Lake Corcoran are interchangeable names that are used for this massive inland sea that connected into the ocean. So here's a visual on the right that is sort of saying like if glaciers were all to melt as of this day, it would flood most of that Central Valley. And that's why we see when it rains crazy here in California, we see this valley sort of want to start flooding. So throughout this time, it is estimated around 25 to 13,000 years ago that we had the first um, paleo people come in to what we know as North America. So a lot of those sites were actually along this well, not this inland sea, but these steps that are now underwater. So we've actually lost a lot of this archaeology. Here we can see a visual of the Monterey Bay and how far into the ocean it actually used to go. So we saw this rise and fall of oceans. So what we know now today, oceans would rise 400 feet above that, and they would also drop 400 feet from what we know today. So we had access to an incredible amount of land back then, and people began crossing through Beringia. So, again, like I mentioned, the Salinas um, Valley might have been carved a little bit more because of the central um, valley inland sea. And here we can see a picture throughout the Monterey Formation, or preceding a little bit of the Monterey Formation. And here's a visual of Salinas on the left and that inland sea. So the dotted land being sediments and mountain ranges here that we can see in the Santa Cruz Mountain, those uh, were pushed up a little bit more and actually formed what we know as the northern Cascades up in like the Oregon area. So, as I mentioned, people began coming over to North America 25 to 13,000 years ago. Those are the estimates. So as oceans fell 400 feet during the last ice age, we had people crossing in multiple theoretical ways. So some people say that um, people might have traveled along the Pacific Ocean, and others say that there was another flow through inland in what we call Beringia. So as oceans dropped, it exposed this land connecting Russia and Alaska that was huge. So we're talking about Texas size. So people were able to cross over. Um, and it gave them access. We have further proof of cultures such as Folsom and Clovis, but other sites are still popping up to this day. And along with people coming over to North America, we also had animals, maybe being one of the motives that people started traveling along with these packs. So we had tons of these animals in North America, such as the American cheetah, direwolf, saber-toothed tiger, bison, mastodons, uh, saber-toothed cats, short-faced bears, Irish elk, woolly mammoth, ground sloths. We have the American lion over here. We have camelops. And a fun fact, but basically, camels and horses originated from the North America. And when that Beringia land opened up various times throughout different ice ages, they went back and forth and they exited and spread to the rest of the world, along with some of these animals coming from other parts of the world into the North Americas. But some of these animals can be seen, and the reason that we know they were here is through the La Brea tar pits. So these tar pits were formed because of the Monterey Formation. The Monterey Formation again went super low under all these layers and actually squished all those marine fossils, and it created oil. Because of the faults, some of that oil went up and created this really deep tar pits where sometimes animals would get stuck, and it's kind of worked as like quicksand. So let's say a mastodon fell into that tar, it wouldn't be able to escape and it would die. And let's say a saber-tooth tiger or cat would try to eat it, and then itself would get stuck and die. And let's say a condor would try to eat it, and then eventually it would get stuck. So it created this unique fossil buildup that we can study today and know what kind of species we had here in the Americas. So these animals might have and probably were roaming around the Salinas Valley. And some other evidence that we have is some of these recent finds. So in 2011, there was actually a pair of Castroville mastodons that were found very close to what we know as the woolly mammoth, with a little bit less hair and a little bit smaller in size. Again, a pair of mastodons were found here. We had Santa Cruz finds, so 1980, 2019, and 2021. So in 2019, there was actually a tooth found in the Santa Cruz area. And then 2019, we had the mammoth skull found in the area. And then in 2021, we actually had a tusk that was found, I think it was like 3 or 4 thousand feet into the Monterey Canyon. So we had like small submarines, basically, like a little robot by Mbari actually help find this tusk. And then recently, throughout the rains in 2024, there was a child that actually found, I think what was a femur of a giant ground sloth in the Santa Cruz area. So it is believed because of all the rain, it created a bigger flow of the river, which this fossil was probably dug under all this mud, and it caused it to come up and be deposited. So I'm sure there's other fossils around in the area, but pretty rare to find such fossils because of all the water activity that has been occurring within the last millions and thousands of years. So um, the Salinas Valley was further carved by this thing that we call the Salinas Valley tilt. And it actually creates more of the natural environment than one might think. So there's this warping that occurs in the Salinas Valley, and it has filled up the Salinas Valley with 10 to 12,000 feet of sediment that we see sand, silt, clay. We can see in this left hand picture all the layers that were deposited. So the three reasons for the tilt that one may argue is the big bend of this San Andreas Fault. So there's this bend that occurs in the slip zone of the San Andreas Fault near Santa Maria and LA, right in between. And this actually has caused a 1,000 foot um, increase in elevation on the southern portion of the Salinas Valley. So again, from Slow to the mouth of the Monterey Bay, there's this big 1,000 foot drop. As you can see here, the bedrock is at a sloped angle. So with gravity, we see the water flow down into the Monterey Bay. Another thing is erosion through the Monterey Canyon. So the Monterey Canyon acts as a drain for the Salinas River and the valley. And this erosion further pushes sediments down into it, and it prevents it from rising up and stacking up throughout the years. So additionally, the weight of the sediments sinking down the valley actually causes the northern end to sink even more while the northern end is still rising. So we kind of have two sides of the valley sort of continuously acting as an uplift and a pushdown and sinking for both sides. And it is also because of this erosion and sort of this downwarp that we see this bay form. So here's how the Monterey Bay looks, but if the land was to be flat with no warp whatsoever, so without it dropping down, we wouldn't have a bay. We would basically have this flat coastal area. But because the valley actually drops in a U and it's a valley, this causes further erosion inland, and it causes this bay sort of formation in the Monterey Bay and the mouth of the Salinas Valley. So another reason also that we see further tilt is underwater pumping. So within the last few years of agricultural development, we've seen wells suck up a lot of this water from the underwater aquifers. Like mentioned, 100, the 180 and the 400-foot aquifers. And all this release of water actually causes these formations underground or aquifers to concave and create further sinking in the valley. Here we see the Selenian block and the Selenian Valley, and we could sort of see the uprising of the Gavilan Range and the Santa Lucias. So I created this drawing, so it's not the best. I couldn't find anything else like it, but we have the Selenian block, which is actually the black formation that I drew here. This is just the mantle on the bottom, so it's mantle. And then we have the lithosphere, which the Selenian block is on top of. We have the Gavilan Range as the blue, and we have the Santa Lucias as the pink. So the way it works is that there's the San Andres Fault that's actually carving out the Gavilan Range and causing it to rise, and it's rising up at a tilt into the Salinas Valley, whereas the Santa Lucias is pretty much rising straight up. So we're seeing higher increase in the Santa Lucia range, rising up over the Gavilan range. And along with these, since we're in between two fault zones, the Salinas Valley is being stretched. So another visual that we could really think about. This is how transpression boundaries are pretty much lifting the land. So again, the San Andres. So imagine you have Play-Doh. If you spread it flat and you rub your hand one down and one up, this is pretty much how a transpression boundary is forming the mountain ranges. So when they both pull in opposite sides, it creates that center ground to be lifted. In the Salinas Valley floor, When these two areas are pulling on each other and pushing the land up, we see this stretch in the center of the valley and the granitic core. So we see the Salinas Valley being stretched thin, and actually it creates this thinning. So if you were to have pizza dough and you were to spread it, it would become more thin in the middle. So this makes the U form of the Salinas Valley. And in recent times, we have some further confirmation and phenomenons actually show us some of these remnants, some of these geological remnants. So as we can see here, the Tulare Lake. So how it looked like at some point, and within the last few rains, in 2024, we had massive flooding in the Tulare Lake. So here's um, some pictures of the Tulare Lake throughout that flooding in 2024. We have Tule fog, which happened this year, and it actually filled up this whole Central Valley. And yeah, I mean, throughout much of the life and creation of the Monterey Bay, um, we've seen this geological morphology shape the land that we have today. Along with this, we have Native American um, myths and creation stories that further align with what we're seeing geologically as the creation story of the Esselen Nation and various tribes in the Salinas Valley area. We see a lot of them talk about going up to the top, the highest point in the mountain ranges to escape flooding, and this being their creation story. So I think there's um, tons of information out there and lots of gaps that still need to be talked about and discovered. But this is like my short presentation um, about the creation of the land and really analyzing how it came to be. But yeah.
Awesome. Thank you so much, Alexis. All right, so let's open it up for questions. Let me see. How do I do that? How do we want to have folks raise their hand and then we'll unmute? All right. Well, if no one has questions, I'll go ahead and just say thank you all for attending. And I put a link in the chat. We are a nonprofit, so Beaver Brigade. And if you enjoyed attending this presentation, we would love to host more events like this and keep them free for everyone to join. So please consider donating. And then one other really exciting thing. If you haven't heard yet, which you might have, we are having our Beaver Festival on April 11th. That's a Saturday, and that's in San Luis Obispo. And we would love it if everyone can join us there. Um, let's see. I see Cooper has his hand raised. Go ahead, Cooper.
Hey, can you hear me, Alexis? I'm really curious about the land bridge that formed between yeah, North America and Asia. And I was wondering with the animals that came over, do you think beavers were one of the animals that they came to North America via the land bridge?
Yeah, that's an interesting question, which I actually don't know the answer to, but I know that various other creatures also came over, like otters, etc., which are more modern that I didn't really pinpoint in my presentation. I think that would be something interesting to note within the next few presentations, but I would assume that there was ancestral beavers that would have came over throughout this time, but I'm actually not too positive as to the fossil records and when beavers came over into the area that we call today the Salinas Valley.
Thanks. That was also super interesting about how the Monterey Trench could have been formed by other river systems. That blew my mind. So yeah, thanks for sharing about that.
Yeah, of course. And like I would recommend like if you guys wanted to look into like the Monterey Canyon, there's like hours and hours of videos by the Mbari. So just search up Mbari Canyon and you see all these thousands of creatures that exist and have recently been found. Again, like I mentioned, like it's almost like Pokemons, like they're crazy out of this world creatures that you can find there. But yeah, thank you so much, Cooper.
All right. Looks like Paul Rose had a question in the chat.
Yeah, very
Do you want
good. How
do
about
you
if
want
I
to
just
say
say
your
it?
question?
She unmuted you.
Yeah. At any rate, so during the more recent ice ages, I'm kind of wondering if there were any ice flows in the Coast Range or in the Santa Lucias. Any known?
You said ice flows?
Yeah, flows, minor glacial activity or anything of that sign. I was hiking up inside of Cone Peak not too long ago, and there's these definite moraine type of formations, and I'm kind of wondering if I'm making it up or if it's from a different formation.
Yeah. From at least like the Santa Lucias and the Gabalans, as to what I know, there was no glaciation. So, and throughout California, like we're pretty much way down here, and we don't see it connected to the big Laurentide ice sheet that was
Mm.
in like near Washington and consumed all the way to New York. But we had them along the Sierra Nevadas, all the way down to like Mount Whitney and stuff. So it spanned pretty far, but I think from the coastal areas, I don't think and there hasn't been any or much evidence found of possible glaciation in these higher peaks. Also around the coast, a lot of these areas were a bit more arid and dry. There was less rain and water along the coast. So we had this natural like grassland type area. So a lot of the animals actually thrived in this California, and this is what they were looking for once they were leaving the Ice Age northern area. So as to what I know and have read, I don't think there has been any glaciation that we're aware of in the Santa Lucias and Gavilan ranges,
Thank you.
of course. Yeah, and I see Audrey like reflecting on how recent some of these fossils are in the Santa Cruz. Some of them are available. I think it's the Santa Cruz Natural History Museum, so you could see. I think it's a replica, or they had the actual, I think, skull of the mammoth. In display, I believe. But yeah, again, if you guys are interested in any of these other Ice Age fossils, the La Brea tar pits in LA, even giving them a Google web search or visiting, incredible what they've found. Yeah, La Brea tar pits. It's sort of interesting seeing like also this 400-foot ocean drop along the California coast because mastodons, or basically similar relative to the mammoths, were able to travel to some of these islands out in the ocean that we see today. For example, in the Santa Catalina Islands off Santa Barbara. And once the oceans rose again, those islands were not accessible from the mainland. So these mastodons evolved super tiny in order to climb on trees and eat some of the vegetation. And they had no natural predators, so they didn't really need the size. And they were pretty much isolated from the mainland. So you had these up and down trends of the um, ocean. But yeah, not sure if there's any other questions out there.
Awesome. Well, thank you so much again, Alexis, and thanks everyone for coming to this presentation. I imagine that you learned a lot because I learned a heck of a lot during that. And yeah, Alexis will be at the Slow Beaver Festival this year, April 11th. So join us for that. And again, slowbeaverbrigade.com/donate is the link to donate, and we appreciate any contributions you can make. So yeah, if that's it, thank you guys so much for joining, and everyone have a good night.
Good night, everyone.
Thank you. Awesome. How do you know all this stuff? Are
Really?
are you a genius? You are a genius. I'll see you on the 11th.
I'll see you guys there. Bye,
Thank you. Nice job.
everyone. Thank you.